Hi everyone, I am Maxine Cho and I'm Product Manager from Advantech.
I'm Edwin, Advantech Regional Sales Manager, covering the ASEAN countries.
In this section, we are going to showcase how AIoT, AI and edge computing are applied in today's factory automation and manufacturing industries. The AIoT technologies are driving the digital transformation of factory automation. Edwin, can you please share the latest trends you observed in smart manufacturing?
Sure, smart manufacturing represents a leap forward from more traditional automation to a fully connected and flexible system. It utilizes connectivity and real-time data to improve a process. Recent trends such as the rise of Industry 4.0 emphasize on the conversion of the digital and physical world. IT and OT, which tends to be segregated, to create an interconnected open systems. We can use a constant data stream from connected operations and production system to learn and adapt to new demands. Today, due to the advent of cloud, faster processing edge computer, vast wired and wireless connectivity options, manufacturers can now gain more data from multiple sources, consolidate and do trending and gain better insights by viewing different dashboards. To improve real-time responses, computing and processing at the edge becomes more important. What are the benefits of edge computing in smart manufacturing? First, more efficient and agile system. Number two, less production downtime. Number three, ability to predict and adjust changes, leading to better positioning in the competitive landscape. The key benefits for smart manufacturing edge computers can be summarized into three main thrusts. First one, predictive maintenance. The goal of every manufacturing plant is to maximize assets availability, minimize downtime. Poor equipment maintenance strategy can reduce a plant overall productive capacity by 5 to 20%. Unplanned or sudden downtime are costly. By practicing condition-based monitoring, one can reduce sudden critical failure that may result in product quality issues. Just imagine the amount of cost savings. Number two, productivity improvement. Smart manufacturing processes provide greater access to data across the entire value chain. Real-time data outlines what the manufacturer needs and when. Thus, becomes more efficient for supplier to make adjustment to orders on demand. You supply what you need, nothing more, nothing less, thereby reducing waste. Knowing the demand means better and more efficient scheduling. Reducing waste means such savings can be reinvested for better product innovations. Number three, autonomous management. Recently, AI, especially in the deep learning arena, are also utilized in smart factories. Future factories eventually becomes one large system comprising hundreds of smaller systems that can operate independently, yet act as one. We can apply certain rule-based scenarios, and each subsystem can use AI, machine vision, deep learning, and edge analytics to communicate with and manage the factory's entire realm of materials, equipments, and production lines. Self-monitoring equipments can detect when quality will suffer due to degradation and then can schedule when it needs to be serviced. Maxim, definitely you have seen some application cases worldwide. Can you introduce some of them?
Sure, Edwin. We do see the trend that more and more equipment builders would like to have not only a reliable controller, but also the ability to collect real-time operational data, send them to either edge server on site or cloud server. The collected operational data then can be used as the database for building predictive maintenance mechanism. This case we share here is a CNC machine builder. Customers use our ARC 1123 as the cutting table controller. Their CNC control software with graphic user interface runs on the ARC Edge computer, controlling the movement of the cutter torch and provides physical control buttons such as the start button and emergency stop. This ARC Edge computer is also equipped with Wi-Fi communication, allows operational data to be collected and sent for further usage. Moreover, remote firmware, software update, and diagnosis are also achievable, which allows our customer to provide better support service and reduce the on-site supporting cost. Wireless communication become a very powerful and essential function for this kind of edge intelligent use cases. It makes the implementation become more easier in different field sites by adopting different wireless technologies. AI-based machine vision is another hot topic for manufacturing. Deep learning technology improves not only the precision level of defect inspection over traditional rule-based AOI, it also reduced the implementation cost and time for a new set of defect features by applying a quick retraining. The video you see is one of our real cases using Edge AI technologies. In this case, our Edge AI analytic platform, AIR300, is used as an on-site retraining server. It has sufficient CPU computing power from an Intel Xeon processor for image preprocessing, and it obtains the real-time images captured by the cameras on robotic arm while the 4 LAN ports. Then it runs the model retraining while the accelerations of an NVIDIA 30 series GPU card. The industrial features and condensed design of AIR300 are also important to fit in field site environment and ensure the reliability of retraining operation. Edwin, as you introduced earlier, predictive maintenance is the next big revolutionary shift in manufacturing. Do you have any real-world use case to share with us?
Of course, one of the major manufacturers for flash chip in Singapore wants to improve their production yield rate and reduces wastage. The flash chips are fabricated from wafers, and wafers are sometimes damaged by issues with their robotic arms. Each wafer are costly, and there is an urgent need to reduce such unnecessary downtime due to damaged wafers. As such, the customers uses our Core i-based EIS-150 edge computers that interface to various sensors, such as vibration sensors and current sensors, to monitor the robotic arm behavior, check on uptime, and at the back end, uses AI analytics to predict patterns of potential failures. These help to vastly reduce the cost of the robotic arm failure, improve schedule downtime, and thereby increases productivity and reduces wastage. After trialing this for a few months, there are significant cost savings to proceed ahead. AI and IoT are already here upon us. There are many application cases and that can benefit from proper selection of each computing platform, be it on the software or the hardware layers. We Advantech offers a comprehensive edge solution that helps provide building blocks for smart factories. In smart factories or smart manufacturing plants, edge computers can be deployed to various different kinds of subsystems. We have a wide range of selection, and beyond this, we also have our own IoT gateway middleware, which we call it Device on IH. This can help SI to do edge pre-processing and then send the appropriate data to the cloud. In terms of platform, we have various fanless embedded PC ranging from Atom to Xeon. So we segregate them from the low to the high end. We have the ARC 1000. These are ultra compact, small size atom-based computers for simple edge analysis or data collection. We have the ARC 2000, that's multi-function, ultra low profile types. Okay? And we also have the ARC 3000 for those that need add-on cards or slot expansions. Okay? For deep learning, We also have another series that can be used for training and inferencing, which we call it the AIR series, AIR. Okay? And also at the back end, instead of everything consolidating to the back-end server, we can also segregate or create edge cloud via our EIS S230 model. Edge computing puts data processing and analytics systems closer to where the data is generated and captured. The idea is to bring content and analytics to the data faster rather than sending all the data to a cloud. Okay, you can straight away process it or for deeper analysis, more real-time response. Okay, so in short, edge computing allows intelligent system to take immediate actions to optimize everything from machinery performance and equipment maintenance to logistic and even supply chain subsystems. For example, you can have fanless controller systems situated near the sensors and actuators, monitor their usage, edge process for faster real-time action, and then relay the data to the backend for consolidation. Some of such edge computers can be deployed with either accelerators, AI accelerators for inferencing, or you can also add in cards, graphics cards or GPUs for acceleration, for training. All these are for edge AI analytics. The images are pre-processed for first stage analysis and then sent to the backend for further processing. Some application cases can be for defects inspection. You can use it to interface with CNC controllers, machine vision, and many others. Integrating different subsystems, you can also adopt edge cloud concept. Edge cloud basically uses container technologies for different subsystems, integrating them and build a dashboard where end users can gain insights based on real-time data and situational awareness. Another scenario can be for warehouse automation. The overall concepts are rather similar. To automate a warehouse further, one can use AGV or robots to scan, to send, to sort, or to retrieve goods. Mini drones can be deployed for video analysis or access to hard-to-reach areas. Similarly, edge cloud can create a centralized management and data visualization, okay, and create customized dashboard for different stakeholders so that they can gain necessary insights of the current situation and what to improve upon. You can refer to our popular DIN-Rail UP 1000 series, ultra-compact model for space-constrained deployment, AIR series, if you need edge AI capabilities with Intel Movidas VPUs options, or even NVIDIA graphic cards, okay, and enhance them to accommodate, we actually enhance this series to accommodate the additional extra thermal load.
Thank you, Edwin. I think that's all for this section, and I hope the information we just shared is useful for you. I'm looking forward to our cooperation in near future to enable your smart manufacturing applications. Thank you and goodbye.
Thanks everyone.